In March 2024, a routine software update nearly granted an attacker control over the world's servers. The only thing that stopped it was a microscopic shift in a computer's performance, a lag lasting exactly 500 milliseconds. This happened inside SSH, the foundational gateway for the modern internet. Administrators use this protocol to log into remote servers, manage banking systems, and secure government databases. It is the primary lock protecting the world's digital infrastructure. A vulnerability here allows an outsider to bypass authentication entirely. If successful, an attacker can run commands as a system administrator across millions of interconnected machines, gaining silent access to almost any computer on the web. While testing a pre-release version of the Linux operating system, Microsoft engineer Andres Freund noticed something unusual. His secure logins were using 10 times more processing power than they should, making the connection take half a second longer than normal. Computer systems glitch constantly, and most developers would have ignored a half-second delay as a minor network fluke. But Freund's decision to investigate the root cause of that specific slowdown uncovered an operation that had been years in the making. Freund traced the lag to XZ Utils, a data compression tool found in most Linux distributions. Inside, he found a sophisticated backdoor, malicious code hidden in a tool designed to compress files. The malware stayed hidden by disguising its components as compressed test files. These files appeared to be harmless binary data used for quality checks, but during installation, a hidden script decoded itself and injected a multi-stage payload into the system. The payload was highly selective. It performed an environment check, staying dormant on most computers to avoid detection. It only fully activated when it detected a 64-bit Linux system using specific build tools, the exact configuration used by Debian and Fedora. Once active, the backdoor intercepted the SSH authentication process. It watched for a specific encrypted signal from a remote user, and when it saw it, the backdoor granted that user full remote code execution without requiring a password. This code was deliberately planted. Security researchers identified the culprit as a trusted project maintainer using the alias Jia Tan, who had spent years working on the software. The complexity of the injection, combined with the patience required to hide it, indicates a level of resource and planning typical of a nation-state. This was a targeted infiltration of a critical digital supply chain. This wasn't a quick hack. It was a campaign that began in 2021. At the time, XZ Utils was maintained by a single, unpaid volunteer named Lasse Collin, who had been supporting the project for over a decade. Collin was managing the project entirely on his own, balancing bug fixes and updates for a tool used by billions of devices. He was suffering from burnout, working under heavy pressure from a community that relied on his free labor. The attackers exploited this. Anonymous accounts, likely controlled by the same group, began bombarding Collin with emails. They criticized his slow pace and pressured him to bring on more help to keep the project moving. Amidst this manufactured pressure, Jia Tan appeared. They started as a helpful contributor, submitting legitimate bug fixes and taking the workload off Collin's shoulders. Over 2 years, they became a pillar of the project, earning the community's trust. By early 2024, Jia Tan had been given full control over the project's repository. They were responsible for reviewing new code and managing the official releases sent to millions of users. Jia Tan used these privileges to bypass the standard review process. They pushed the backdoored code into the official updates for XZ Utils, ensuring the malware would be automatically included in the next major Linux release. The attackers weaponized the project's social structure, using the psychological strain on a lone volunteer to bypass the technical security of the entire ecosystem. When the backdoor was discovered, the clock was running out. The compromised code was already in the testing versions of major Linux distributions and was scheduled for a global rollout within weeks. If those updates had reached production servers, attackers would have gained unauthenticated access to the backend of the global economy. They could have stolen data, crippled infrastructure, or monitored encrypted communications on an unprecedented scale. This incident reveals a systemic flaw in the Internet's foundation. The trillion-dollar tech industry is built on a massive collection of open-source tools, many of which are still maintained by unpaid volunteers working in their spare time. Nation-states have identified this as a primary attack vector. They no longer need to find zero-day vulnerabilities in every piece of software. They only need to wait for a single critical maintainer to burn out. The internet avoided a generational crisis because one engineer investigated a 500-millisecond delay. We were saved by a stroke of luck, but unless the industry changes how it supports the volunteers who build its foundational code, the next infiltration is unlikely to be caught.